Hi, I'm Aditya Bihara, and this is my Physics 2211 Lab 1 video report. In this lab, we will investigate an object in motion with constant velocity and constant direction. What that means is that there is no net force applied on the object while it is moving. As you can see, the normal force and the force as a result of gravity are the only forces being applied on the cart, and they both cancel each other out. In this lab, I will use Tracker to measure actual data of a cart rolling down a track. I will also use GlowScript to create a computer model to predict the cart's motion. After that, I will compare the measured data and the predicted data and draw some conclusions. In this experiment, the object that causes the initial force to push the cart will be considered part of the surroundings. The cart itself and the track will be considered part of the system. The initial conditions in this experiment are that the cart has a mass of 1 kilogram, the initial time is at 0 seconds, and the initial position vector of the cart is 0.104, 0, meters. Because the time is set at 0 when the motion begins in Tracker, and y and z are not relevant to the motion since the motion only occurs along the x-axis. Once the cart is pushed, the force of gravity and the normal force cancel each other out, and since there is no other force being applied, the object stays in constant motion. Because an object in motion stays in motion when no outside force acts upon it, according to Newton's first law. In Tracker, I'm using a small screw on the top of the cart as my point of reference when tracking the object. The track itself is 1 meter across, and I'm using the plus x-axis as going in the direction of the cart's motion. So, without further ado, here is the video of the cart being pushed down a track and being tracked using Tracker. As you can see on the right-hand side, we have a plot comparing the position along the x-axis to time of the cart, and we have a table at the bottom comparing the time, the x position of the cart, and the instantaneous velocity at each of those positions for all the 81 tracked points I was able to gather. In the GlowScript code, we'll be using the velocity update formula and the position update formula, which are both derived from Newton's second law, F equals ma. You can see the velocity update and position update formulas on the screen right now. According to the data we gathered, the initial time is 0, the final time is 2.667 seconds, the initial position along the x-axis is 0.104, and the final position along the x-axis is 1.01. To calculate the average velocity, we use x final minus x initial all over time final minus time initial, which gets us 0.3397 meters per second. Using this information, we can create a initial position vector and an initial velocity vector. As you can see, the initial ball position vector and the initial ball velocity vector are exactly the ones I described in the previous slide. For delta t, we are using the final time, 2.667 seconds, divided by the 81 steps that I was able to get on Tracker. As you can see, the final time, 2.667 seconds, is used as the conditional in the while loop. The net force has a vector of all zeros because there was no net force applied on the cart after it was moving. The velocity update formula is used in the while loop to keep on updating the cart's velocity, and the position update formula is used to keep on updating the cart's position. We also add delta t to t to keep incrementing forward, and we print out the ball's position at each step. As you can see, after running the GlowScript code, we have a position versus time plot and a velocity versus time plot, as well as a table of data that the GlowScript code generated. As you can see, when comparing the measured versus predicted data in a position versus time graph, there is some error. I believe the reason for this error is because the computer model does not account for friction, air resistance, or the uneven ground the track was laid on. Also, there was likely some user error when making these measurements. When I set my axes in Tracker, I made the choice to have the positive x-axis go in the direction of the cart's movement, so that all my answers would have just stayed positive. So if I had made the negative x-axis go in the direction of the cart's movement, my answers would have all been negative as well. So, for example, the average velocity I found would have been negative 0.3397 meters per second instead of 0.3397 meters per second along the x-axis. Additionally, the computer model was perfect and assumed that the net force acting upon the cart was non-existent. In reality, friction and air resistance would have been acting upon the cart and would have caused the system to have some net force. Thank you for watching my Physics 2211 Lab 1 video report.